Jai Gurudev, welcome to 11th Physics. See, in 11th standard, first lesson is measurement. Already familiar in your lower section measurement, but here also just you recall that. In the case of measurement, I focus only units. What's the need of unit, how to use, and how will you convert from one unit to another one. Clear? Shall we go for a lesson? Okay. Measurement is the first lesson in 11th standard. See the picture that shows everyday life. How do you measure? For measurement of mass, digital meter, measurement of volume, and measurement of length, measurement of temperature. These are all daily life we are using. So from that one, you can ask one question: what is the need for measurement in physics? See, the experiment require measurements. And we measure several physical properties like length, mass, time, temperature, pressure, etc. So experimental verification of laws and theories also need measurement of physical properties. Okay, the physical quantity. What is physical quantity? Physical property that can be measured and described by a number is called physical quantity. For example, mass is a physical quantity which is measured by a number, that is mass of the person is 65 kg. Length of the table is 3 meter. So these are the example for the physical quantity. And next one, the physical quantity can be classified into two types. One is fundamental quantity, another one is derived quantity. Fundamental quantity, what is a fundamental quantity? The quantity which do not depend on any other physical quantity. That is called fundamental quantity. For example, mass, length, time, temperature. But in the case of derived quantity, which can be depend, the quantity which can be depend on fundamental quantity, that type of quantities are called derived quantity. For example, area, volume, speed, force. Why do I say the quantity, derived quantity which depends on fundamental quantity? For example, area means length into breadth. Length is a fundamental quantity, breadth also another fundamental quantity. So we are using, based on the fundamental quantity, we derived the next one quantity, that is called derived quantity. Then unit for measurement. The standard used for measurement of a physical quantity is called unit. For example, metre, foot, inch for length, and kilogram, pound for mass, second, minute, hour for time. So this is the way they are using units. And what are the characteristics of units? That means the units are well defined, suitable size, reproducible, invariable, indestructible, indestructible, and then internationally acceptable. And next one, in olden days they were used three system of units: CGS, MKS, FPS. What is CGS? CGS system was introduced in France. This was known as Gaussian system of units. It is based on centimeter, gram, and second. That means as a fundamental unit, length, mass, time. For centimeter, measured for length, G, gram, used for measuring mass, a second is used to measure for time. Based on that is known as CGS system. MKS system, it was introduced in France. This system was known as French system of unit. It is based on meter, kilogram, and second. That means M stands for meter, K stands for kilogram, S stands for second. The three fundamental quantity can be measured by this system. Next one, FPS system. This was introduced in Britain. This was also known as British system of unit. It is based on foot, pound, and second. Foot used for measuring length, pound used for measuring mass, second used for measuring time. And finally, nowadays we are using SI system. What is the SI system? International System of Units. That is General Conference of Weight and Measures held its meeting and decided a system of units for international usage. This system is called International System of Units and abbreviated as SI from its French name. The SI unit consists of 7 fundamental units and 2 supplementary units. See, what are the 7 fundamental units? Length, mass, time, temperature, electric current, luminous intensity, and amount of substance. These are the fundamental quantity. Okay, definition for meter. What is how will you define 1 meter? The meter is the length of the path traveled by a light in a vacuum during a time interval of 1 by 29, 97, 92, 458 of a second. The same way you can define the kilogram. Kilogram is the mass of prototype cylinder of platinum iridium alloy preserved at the International Bureau of Weights and Measures at Severs near Paris. See, this is a platinum iridium alloy kept at the Paris. Based on that, throughout the world we measure the mass. And definition for second. 1 second is the time taken by 9, 19, 26, 31, 770 oscillations of a light emitted by a cesium-133 atom. How much of time required to oscillate this much of oscillation for cesium atom? That is 1 second. And I told you 2 supplementary units. One is radian, another one is steradian. What is this? Radian. Radian used to measure the plane angle, steradian used for measuring solid angle. And also you should know how to write the units. For the rules for writing SI units, first rule, the full name of unit always starts with the small letter, even if the named after a person. If the scientist name is, you have to write only small letter. Don't use capital letter for Newton, N. Clear? Newton, Ampere, Coulomb. These are all the scientist names. So you should write only small letter units. Next one, the symbol for unit named after scientist should be in capital letter. Don't get confusion. First I told you unit. Now I told you symbol of unit. Newton means you can write capital N. That's enough. For capital N means if any scientist name, you have to write only capital N. That is Newton, or you can write small letter Newton, Kelvin, Ampere, Coulomb. You have to write anyone for unit or symbol of unit. If any person name come in the unit, you should write capital letter. That's it. Symbol of unit should be written in capital letter. Symbol for all other units are written in small letters. For example, meter is not a scientist name, so you have to write only small m. Symbol for the unit. Underline symbol for the unit, not a unit. Second, you can use for S. Small s enough. Don't write SEC sec. See, somebody they are writing very wrongly. The second means SEC. Don't write SEC. One type. What is it? You have to write S, or you can write second. That's all. Kilogram, kg, candela, cd. These are all the symbol for the unit. And fourth one space is left between the last digit of numeral and symbols. For example, 10 kg means 10 space kg. 5 Newton means 5 space n. This is the way. Don't write 5n. 5 without space n means that is wrong. And the rules for writing fifth point, which is that units do not have plural form. 6 metre, that's all. 6 meters, that's wrong. 14 kg, not 14 kgs. 20 second, not 20 seconds. So don't write plural form. And next one, full stop should not be used after the units. Don't use full stop at the end of the unit. For example, 7 meter. Don't write 7 meter full stop. Seventh one, no spaces between the symbols for units. For example, 4 joule second means you have to write 4 space joule second. Don't write 4 space joule space s. That's wrong. And finally, can come to the what's that prefix. SI prefixes. For example, already familiar in the lower section. 10 power 1 deca, 10 power 2 hecta, 10 power 3 kilo, 10 power 6 mega, 10 power 9 giga, 10 power 12 tera, 10 power 15 peta, 10 power 18 exa, 10 power 21 zeta, 10 power 24 iota. The same we can go for other side. 10 power minus 1 deci, 10 power minus 2 centi, 10 power minus 3 milli, 10 power minus 6 micro, 10 power minus 9 nano, 10 power minus 12 pico, 10 power minus 15 femto, or it will call as a Fermi. Fermi also 10 power minus 15 meter. See, 10 power minus 18 auto, 10 power minus 21 septo, 10 power minus 24 yocto. This is the way you have to use the prefixes. For example, 3 milliampere. Milli means 10 power minus 3. You have to write 3 into 10 power minus 3 ampere. Same way 6 picometer. Also 6 picometer. 6 into pico means 10 power minus 12 in meter. 7 megawatt. 7 into 10 power minus 10 power plus 6. Mega means 10 power 6. So you can write 7 into 10 power 6 watt. This is the way you have to write. Some practical units for measuring length. For example, bacteria in the range of micron, molecules in the range of nanometer, or nanometer 10 power minus 9 meter. And also for length, for atom in the range of 10 power minus 10 meter. For the case of nucleus, 10 power minus 15 meter. This is the diameter of the nucleus. This is the diameter of the atom is 10 power minus 10. Diameter of the nucleus 10 power minus 15. This is all the range. Some practical units for measuring length, already familiar. Astronomical unit and light years are used for measuring length. What is astronomical unit? It is defined as the mean distance of the earth from the sun. One astronomical unit is equal to 1.5 in 10 power 11 meter. Some practical unit for measuring length, light year. I told you what is light year. It is a distance travelled by light in vacuum in 1 year. That is value 9.5 into 10 power 15 meter. And also one more unit are used for measuring the length, that is a parsec. It is defined as the distance at which an arc of 1 angstrom unit subtended at an angle 1 degree. Its value is 3.1 into 10 power 16 meter. And then you can go for area. Some practical unit for measuring area. 1 acre equal to 4046.8 meters square. 1 hectare equal to 1000 meters square. 1 barn equal to 10 power minus 28 meters square. Some practical unit for measuring mass. 1 atomic mass unit equal to 1 by 12 into mass of the single carbon atom. That value is 1.66 in 10 power minus 27 kg. It is the smallest practical unit for measuring mass. It is used to measure the mass of the single atom, protons and neutrons. Some practical units for measuring time. 1 solar day 24 hour, you know that. 1 sidereal day 23 hours into 23 hours and 56 minutes. Solar day 365 solar day. Am I right? A lunar month 27.3 solar day. 1 sec 10 power minus 8 second. So this is the way. I hope you are understand the concept. So next class we will discuss the next topic. What is it? Equation of motion. I will derive the equation of motion by 2 method. Okay, next class we will see. Thank you. Have a nice day.